Over here we are on the conversions. We actually did with the conversions in the class as well. But let me revise it for you guys, and you can see the working as well from here. We were studying three types of the number systems that are binary, hexa, and decimal. So obviously we will be having six type of the conversions, that is from the binary to the decimal, decimal to the binary to hexa, hexa to binary, hexa to decimal, and decimal to hexa. So we do have six types of the conversions. We discussed in the last class that how are we going to convert from the binary to decimal. It's quite easy. For example, you are provided with the number 11001011. That's a number for you guys in the binary, and you need to convert that into the decimal. What you just simply need to do, or what I have done over here, you may see that I have multiplied each and every digit by 2, and I have given the power for the 2's from the right hand side. 2's power 0, 2's power 1, 2's power 2, 2's power 3, and so on till 2 power 7. Now when I'm going to multiply 1 by each and every power, so I will be getting the answer 128, 64 zeros, because anything multiplied by the 0 will give you the answer 0. Again, anything multiplied by the 0 will give you answer 0, then 2 power 3 is 8, then it's a 0 once again, then 2, and then finally 1. If I'm adding them all together, so I'm getting the answer 203. Am I clear till over here? Any issues in this method? Yes or no? If it's a yes, no issues, then give the thumbs up. And if you are facing any kind of difficulty, so please ask me. Okay, I got a thumbs up from Tuba, Sara, and Ariba as well. Please, can you let me? Can you please answer me? Okay, Sara. Sara, are you there? Okay, please, Sarah, I would highly recommend you to open up your mic, and if you're not opening up your mic, so please answer on the chat as well. Okay. Now we are coming towards the alternative method. Now, what's the alternative method of this? Alternative method is something that you first of all write down each and every bit separately, 1 1 0 0 1 0 1 1, and just give the denominators, or you may say just give the power to those who are on. Like first one from here, it's on, so it will be a 2 power 0, so you can directly write the answer of the power. That's 1. 2 is on, 2 power 3 is, or 2 power 2 is off, that's 4, so I haven't written 4. Then 8 is on, 16 and 32 are off, 64 is on, and 120 is on. You just simply need to add them all, those who are on, and you will be getting the answer 203 once again. So is this one clear as well? Yes or no, please guys?
Yes.
Thank you. Ariba and Tuva, thumbs up. And if you can open up the mic, that's quite great. Okay, thank you, Tuba. Ariba, better be quick. Thank you, Ariba. Okay, now we're coming towards the decimal to the binary. Binary to decimal, we got the answer 203. Now for the decimal to the binary, I'm just reverting that thing. I made the answer as a question over here, 203, and now I need to convert into the binary. How am I going to convert into the binary? So it's 2, I will be taking up the LCMs. So 2 ones are 2, sorry. And then over here, 0 is not divisible by 2, so I will be placing up the 0 because this digit has been wasted over here, okay? Now again, 2 ones are 2, remainder will be 1. 2 5s are 10, and 1 cannot be divided by 2, so I will be placing up a 0 over here, and 1 will be at the remainder. Then 2 25s are 50, remainder is 0. 2 12s are 24, remainder is 1. 2 6 are 12, remainder is 0. 2 3s are 6, remainder is 0. 2 1s are 2, remainder is 1. Now, how are we going to have the answer? First of all, from left to right, this I made up arrow over here. First of all, from left to right, and then from bottom to top. So I will be getting the answer 1 1 1 1, and over here 1 1, and then 0 0 1 0 double 1. So in this method, I am going to convert my decimal number back to the binary number. Is it clear? Yes or no? Thank you, Riba. Tuba. Okay, Sarah, great. Tuba, beta. Thank you so much. Now we're coming towards the binary to the hexa. Now you are given with the number 1011, 0101, and finally 01 base 2, and you need to convert it into the hexa number. As we know over here, that hexa works on how many bits? Will you please answer me on chat? Hexa works on how many bits?
16.
Number of the bits, not the base. Number of the bits. Hexa is working on how many bits?
4.
4 bits. Great enough. As hexa is working on 4 bits, so what you're going to do, you will be pairing up for 4 bits, and pairing always starts on the right hand side. I've written over here as well. Pairing starts on the right hand side. So first pair is going to be 1 0. Let me highlight that for you as well. First pair is going to be 1 0. Right. 1 0 1 0. It will be the first pair, as you can see over here. Okay. Then the next pair is gonna be what it's going to be. It's going to be 1 0 1 0 was the first pair. Then the second pair is gonna be 1 0 double 1 as I've written over here, and finally the last pair will be 1 0 0 1. And for the 0 1, but we need to complete for the complete all bits. So for those all bits, what we need to simply do, we need to place up the zeros over here. Okay. The student who has recently joined, I would highly recommend you to please turn to your original name, so that it would be easier for me to just remind that who is present in the class. Okay, so first pair from the right hand side, we will be giving the power for the twos 1, 2, 4, 8, again 1, 2, 4, 8, and finally again 1, 2, 4, 8. Now, what is the answer from the left hand side? 8 is off, 4 is off, only 2 is on. So 2 will be the answer for the first pair. Then for the second pair, this one I'm talking about, 8 is on, 4 is on, 12, 12 plus 1,
13.
13. But we do not write 13 over here. So as you cannot write 13 over here, so instead
Uh,
of 13, sorry, you are saying something?
D.
We will be writing up a D over here. So I just wrote up D over here, as you can see. For the last one, it's 4 is on and 1 is on. So what will it make up? 4 is on and 1 is on.
5.
5. Great enough. So we got the answer 2D5 base 16. We actually converted the binary number into the decimal number. Is this a step clear to you guys? Oh, sorry, or is this procedure basically clear to you guys? Okay, I got the answer from Ariba. You as well, Sarah. And the student who has recently joined, let me remind you that if you are clear with this thing, so please give a thumbs up. And please switch your name to your original name as well. I don't know whether she's getting my points or not. Okay. Hexa to binary. Now for the hexa to binary, what we need to do. Okay, thank you so much. Hexa to binary. Now the answer 2D5 became the question over here. 2D5 base 16, and we need to convert it into the binary format. What are we gonna do? We are simply, first of all, we are going to write the digits separately. 2 separately, D separately, and 5 separately. Now I need to represent each and every digit on the 4 bits because hexa is working on 4 bits. So for 2, I just wrote over here 0, 1, 0, 0. It will be 1, 2, 4, and 8. And again, 2, 4, and 8. Okay. So 2 is represented, only second bit will be on, otherwise all will remain off. For D, it makes up a 13. So how does it make up a 13? 8 will be on, 4 will be on, 2 is gonna remain off, and 1 will be on 13. And for 5, 4 and 1 are on. So in this procedure, they make up a 2D5 for the binary. Now, obviously, when we are going to write the answer, we just simply need to merge all those bits. So how are we going to merge all those bits? We can omit these initial zeros that I'm highlighting right now. Okay, we can omit these zeros. The reason behind that, why we can omit these zeros because if I'm gonna write 0 in the initial of any kind of the number, that does not make a sense, or you may say that's a useless 0. So we can write it down 1 0, like we can start from here. 1 0 1 1 0 1 0 1 0 1. We can merge them all together, and that's the final answer that we are getting over here. Is that clear? Any issues still here? Okay, I got the answer from Ariba. Faria, Sara, Tuba. Faria and Tuba. Faria and Tuba. Okay. Tuba is saying explain it again. Okay, no issues. Okay, Tuba, just have a look. Just give me a second, please. Okay, what we just simply need to do, I'm explaining it, I explain it again. Please just listen it now. Okay, we were given with the we were provided with the number 2d5. Okay, for 2d5, what are we gonna do? We need to represent each and every number on 4 bits. So for 2, what are we gonna do? Uh, the representation for 2 on the 4 bits is 0010. What is it? It's 0010. You can see that from the conversion table as well. And if you do not want to see it from here, you can just simply see over here that it's a 0 over here, 2 is on, 4 will be off, and 8 will be off. So in this way, that makes up a 2. Okay, is it clear that how did I make up a 2, Tuba? Okay, now for making up the D बनाने के लिए हमें क्या करना है? We do have 4 bits again, 1 2 4 and 8. So सारा बेटा, what we need to do, हमें क्या करना है यहाँ पे? D is a 13. Now to make up a 13, what are the bits that I need to get on? हमें कौन कौन सी bit on करनी पड़ेगी? We need to get up on with the 8. हमें 8 on करना चाहिए, हमें 4 on करना चाहिए, क्योंकि 8 और 4 आपके पास क्या होता है? 12 बन जाता है. एंड दोज बिट्स दैट आर ऑन, जो बिट्स आपके ऑन है वो आपके पास क्या होगा? वो आपका एड अप हो रही है. ठीक है. सो 13 बनाने के लिए हमें सिर्फ 1 और चाहिए था. सो आई जस्ट मेड अप अ 1 as an on. So 8 plus 4 plus 1 makes up a 13. And similarly it goes for the 5. अब आपके पास आंसर लिखने का प्रोसीजर क्या है? जस्ट मर्ज देम ऑल टुगेदर. 1 0 1 1 0 1 0 1 0 1. आपने सबको मर्ज करके लिख देना है. एंड इनिशियली जो आपके पास 2 बिट्स थी 0 0 की, यू कैन ओमिट देम. द रीजन इज किसी भी नंबर के स्टार्टिंग में अगर 0 लिखें तो उसका कोई फायदा आपके पास नहीं होता है. इज दैट क्लियर नाउ? Okay, Sarah, thank you so much. Ariba got that. Faria and Tuba. Faria and Tuba. Okay, thank you so much. Now we're coming towards the hexadecimal. So before coming towards hexadecimal, what you need to do, just you need to learn the table of the 16 by heart. 16 into 1s, or 16 times 1s is 16, then times 2 is 32, then times 3 is 48, and so on till times 10. It makes up a 160 till here. Okay, you need to learn this table by heart. Now for hexadecimal, just suppose that you are provided with a number A to 9. आपको एक number दिया हुआ है A to 9. It's in the hexa format and you need to convert it into the decimal format. आपने इसको किसमें convert करना है? Decimal format के अंदर convert करना है. What's the procedure of converting that? First of all, what you need to do, just convert A into the numeric format. A is the alphabetic representation of a number 10. A आपके पास किस चीज का alphabetic representation है? 10 की representation. So 10 आपके पास 16 से multiply हो जाएगा, 2 आपके पास 16 से multiply हो जाएगा, and 9 आपके पास 16 से multiply हो जाएगा. When you're multiplying, then now you need to put up the powers. 16 power 0, then 16 power 1, and then 16 power 2. So 16 power 0 is 1. So 9 is going to be multiplied by 1. 16 power 1 is 16. So 2 is going to be multiplied by 16. And 16 power 2 is 256. So 10 is going to be multiplied by 256. Now you can see a small cross over here. What does that cross means? This cross means that you are not provided with too many marks for showing up the working over here. So you can omit the first step and you can directly start from the second step. Like the third number will be multiplied by 256, second number will by 16 and first number by 1. You won't be getting a number greater than 256. The reason is 256 से ज़्यादा मल्टीपल नहीं आएगा आपके पास. क्यों नहीं आएगा? क्या रीज़न है? Because O levels says that you need to perform the task on 12 bits in your O levels. So if I'm going to represent, there are 3 numbers over here and each and every number is represented on 4 bits. क्यों आपके पास 4 bits पे represent हो रहा है? क्योंकि आपके पास ये hexa का number and hexa uses 4 bits for the representation of every digit. So A आपके पास 4 bits पे, 2 आपके पास 4 bits पे, तो 4 plus 4 8 और 9 आपके पास 4 bits के ऊपर, तो overall आपके पास 12 bits बन गई. So if I'm gonna represent, so overall I'm getting 12 bits. So you won't be getting a number more than 12 bits. That means you won't be getting a number more than 3 digits. Okay? Am I clear with this point? Ariba, Faria, Sara, Tuba. Faria. Thank you so much. Okay. Now 10 multiplied by 256 gives us a 2560. 2 multiplied by 16 gives us 2 or 32, and 9 multiplied by 1 gives us a 9. Adding them all together, I got the answer 2601 base 10. So this is how you need to convert a hexa number into the decimal number. Clear with this step as well? Yes or no, guys? Okay, thank you, Ariba. Thanks for your Sarah done, Tuba. Okay. Because you are converting that into a decimal number. Decimal की base क्या होती है तुआ बेटा? तुआ बेटा decimal की base क्या होती है आपके पास? 10 होती है. That's the reason I wrote up 10 over here. Okay. Got this point? Okay, thank you. Now we are moving to the last part, that's decimal to hexa. Now how you need to convert a decimal number into the hexa number? You are provided with the number 2601 base 10. You need to convert it into the base 16 number. How are you going to convert it? 16 2601 is given to us. So 26 is not divisible by 16. So the nearest, the smallest number to this 226 is 16 over here. Okay. The nearest smallest number to 26 is 16, and how many times? 16 ones are, yeah, 1 times are 16. Obviously 10 will be left, so 10 over here merges with the 0, that makes up 100. Now the smallest nearest number to 100, yes guys, on the chat, smallest nearest number to the 100. Smallest nearest number to the 100. Ariya, Ariba, beta, smallest nearest number to the 100. Okay, 16 times 6, 96.
96.
Yeah, 16 times 6 is 96. 16, 6 and 96, remainder will be 4. Obviously, 100 minus 96 is 4. So this 4 merges with this one, makes up a 41. क्या आपके पास क्या होगा? merge होके क्या बना रहा है? 41 बना रहा है. So what's the nearest number to the 41? The smallest nearest number to the 41? On the chat.
32.
32, great enough. 16, 2 times are 32 and remainder will be 9 over here, because 41 minus 32 makes up a 9. Now 16 ones are 16. 2 is not divisible by 16, so we will place up a 0 over here and 2 will be the remainder. Now the procedure to write up the answer is, We cannot write 10 in hexa, so we need to use the alphabetic representation of the 10, and the alphabetic representation of the 10 is a 8 to 9, and the base is 16 base because we use hexa uses the base 16. Am I clear with this step as well? Okay, Sarah, thank you. Tuba, Faria, and Ariba. Okay, Faria, Ariba. Oh, sorry, Faria and Tuba. Faria, am I clear? You need to ask something. Faria, beta, am I clear or you need to ask something? Okay, thank you, Faria. Okay, now what you need to do, these are the homework tasks that you need to bring by tomorrow, okay? These are 10 questions, what you simply need to do. The first question is given to you guys, 10011110011. It's in the binary format, okay? Can you convert this binary number into the decimal number? If it's good enough, so give the thumbs up. Okay, Ariva says yes. And Tuba, can you convert it into decimal? Tuba, okay, thank you. Okay, once you are getting the answer, like for example, for the first one, you will be getting the answer 133. Sorry, you will be getting the answer 307. Okay, 307 base 10. That will be a decimal number. Okay, now can you convert that decimal number back to the binary by the LCM method? Yes or no?
Yes.
Ariba, Faria, and Tuba, you can give a thumbs up if you say yes. Ariba, Faria, and Tuba. Okay. Now you are provided. Okay, now you are done with the 20 questions right now. Binary to decimal and decimal to binary. Okay, now come over here. You are provided with binary numbers over here. Can you convert it in the hexa format by making a pair of 4 bits? Yes or no, guys? Yes, Ariba says yes. Faria, Sarah, and Tuba, can you convert them? Sarah says yes.
Yes.
Okay, Tuba. Okay, great enough. So you are given with 30 questions now. Thank you, Tuba. Okay, when you're getting the answers in the hexa, like for example, for this one, you will be getting the answer in hexa is 133, base 16. So can you convert that back towards the binary? Tuba says yes. Sarah, Faria, and Ariba. Okay, Sarah and Ariba. Great enough. These are 40 questions now. Okay, now we are left with two, hexa to decimal. Now you will be saying, sir, you haven't given us the the questions for the hexa. So when you will be getting the answers for binary to hexa, these answers will become the question for hexa to binary as well as the questions for hexa to decimal as well. Is this thing understood? Faria and Tuba. Tuba. Okay. The last thing you are left with is decimal to hexa. You will be getting the answers in decimal over here. Can you convert them back into the hexa? Tuba says yes. Ariba, Sarah, Faria. Faria beta. Okay. So so these are 60 questions in all. So for your ease, guys, like you are not provided with a lot of time today, so you can solve the first 5 of them. So they will make up 30 questions in all. Okay. पहले वाले 5 को आप लोग solve कर सकते हैं. And I will be checking these 5 questions by tomorrow. The complete work along with the 5 questions, 6 parts. Okay, so I will be checking them by tomorrow. Do complete it before the class. And for this thing, you can take the screenshots right now, and you can copy it down afterwards. Just take the screenshot, guys. Taking the screenshots still here? Okay, that's binary to decimal. Take the screenshot for this. Then it's from decimal to binary. Take the screenshot for this as well. That's your homework questions. Take the screenshot for all. That's binary to hexa and hexa to binary. Take the screenshots for both. That's your table of 16 and hexa to decimal. Take the screenshot. Just hold on. Now you can take the screenshot for table of 16, hexa to decimal, and decimal to hexa. Clear till over here, guys? Any queries till here? Clear. Sara, Farian, Ariba. Okay, Farian, Ariba. Farian, beta. Thank you so much, guys, for the class. I'm sending you the recording as well. If you're finding any kind of the difficulty while solving the questions, you may send me a message. Otherwise, you can take the help from the recording as well. Thank you so much, guys. Allah Hafiz.